and how the race to the cloud creates new security concerns for developers to cope with as computing resources turn into infrastructure code. Liran Tal, developer advocate at Snyk, joins us with more. And I got to say, love the hat. Over to you, Liran.
Thank you, JD. So I guess we'll get started. Hi, everyone, and thank you for joining my talk. Are we forever doomed by software supply chain security risks? Let's take a moment to reflect on this picture. When you look at this photograph, what comes to your mind? Is it a futuristic outlook of the world, or perhaps the uprising of our robot overlords? For me, I ask myself, how much does the robot learn about my child? And where is this information stored? Is it stored safely? How much I think about where does the robot get its software updates from? And can this upstream source be compromised? What can happen when it gets compromised, not just if? What's the probability that someone hacks in and can watch the video feed and talk with my child? These are some of the things that keep me up at night. Today, I'd like to share with you real-world stories of how developers play a fundamental role in recent and growing security incidents, why you should care about software supply chain security, and leave you off, finally, to think about where do you put your trust. In 1984, the Turing Award-winning Ken Thompson wrote a short essay titled Reflections on Trusting Trust, in which he describes how he added a backdoor to the Unix login program, and then he continued and added a backdoor to a C compiler. And then he further continued this chain of attack by backdooring the compiler that compiles the compiler. In his revelation of how software can be taught to learn specific traits and then pass them on to their spawns, other programs created by them, he explains how software can remain without a trace of a Trojan horse because of the dangers of trusting code that we did not entirely create ourselves, from the application code and all the way up to the compiler, the assembler, and the CPU, and so on and so on. As we learned by Thompson's Trojan horse story, dating back from 1984, developers have been targeted as a vehicle to distribute malware and backdoors for a long time now. Let's explore some of these recent events. In 2018, the JavaScript ecosystem witnessed its first high-impact spearheaded surgical attack targeting maintainers and developers working in open source, and themselves being used as an attack vehicle to distribute malicious JavaScript code designed to decrypt itself and run in a specific environment, targeting developers of a Bitcoin wallet application. This was the well-known event stream security incident. Event stream existed on the npm.js registry since 2011, practically did not receive any new releases in the last 2 years, but gained millions of downloads per week. Out of the blue, a person shows up on the GitHub repository, opening an issue and wanting to help, as is customary in open source. They further contributed code with several pull requests, and then they also created a code pull request that adds a dependency into event stream's own package dependency tree with a supposedly genuine intent to improve the code base for event stream. A few weeks later, they added a code payload inside this dependency they added, which injects malware into a specific Bitcoin wallet application called Copay. Because that Copay wallet application used event stream as part of the entire build process, this has resulted in malware basically impacting the Copay app. This had gone unnoticed for almost 3 months, resulting with 2 versions released with the Copay Bitcoin app that influenced the malware and included it. An academic research paper published in 2019 investigated the properties of language-based software ecosystems and found that 61% of open source packages on NPM could be considered abandoned because they did not receive any release in the prior 12 months. As if we didn't learn anything from the event stream incident, 1 year later, the electron-native-notify incident took place. What happened, you ask? At one point in time, an existing version of electron-native-notify has no malware in it. A user adds it as a dependency tree of a popular package. Then that user releases a new version of the Electron package, which now includes the malware. The result is that the Agama crypto wallet is built with the most recent version of the upstream EasyDex package that now includes the malware. Sounds familiar? Exactly. A Snyk-led security research in the CocoaPod mobile applications ecosystem identified malware in the Mintegral Ad SDK. The Mintegral Mobile SDK is used for advertising attribution for mobile apps and was downloaded more than 1.2 billion times a month, integrated into thousands of applications. These downloads are all of us, you, me, everyone here, users of various mobile applications downloaded from an official app store. What Snyk found interesting is that this SDK had a proprietary obfuscated piece of code hooked into sensitive and careful system APIs on mobile, which shouldn't be commonly used. This alerted a potential suspicious behavior. What did it do exactly? It intercepted all HTTP requests. To avoid detection, the SDK detects debuggers and jailbroken devices to stealth itself. And lastly, Snyk found that the SDK installs a backdoor used as a command and control instance. How much thought are we giving to the security of our own development infrastructure? Resources like your cloud instances, your staging environments, or your build and continuous integration tooling. In January 2021, a security researcher broke into Microsoft's Visual Studio Code GitHub repository, essentially providing him with the capabilities of making code modifications to the popular and very well-loved IDE that many developers use. Due to a command injection flaw that was made possible as a valid attack vector based on a flawed regular expression, simply by opening a new code pull request, the researcher was now able to execute code that the VS Code CI scripts were running without requiring any sort of authentication or authorization checks. This led to remote reverse shells on the CI servers, and from there, the ability to gain push and write access to the repository's source code. Fortunately, the researcher responsibly reported the flaw to Microsoft before advanced threat actors could exploit it. How much do we know about the current state of open source security and what it entails? In an effort to explore the security awareness of the Python and the JavaScript open source communities, a group of researchers investigated how maintainers work in the open source community with regards to their ability to mitigate security vulnerabilities. One of the research questions was, how quickly do open source maintainers mitigate a new published security vulnerability? The research found that it takes about 100 days on average for both JavaScript and Python maintainers to start mitigating a public vulnerability. You should ask yourself, is that fast enough for you as a consumer of a library? If we examine the number of commits that mitigate a vulnerability out of the total number of commits, we can see that the Python community has a more consistent track of security mitigation, whereas the JavaScript community was largely inactive with this regard until 2018. This demonstrates the low levels of AppSec awareness around the JS open source community in the early days before 2018. As a case study, we refer to Marked's own security vulnerability from several years back. Marked is a markdown parser for the web, downloaded millions of times a week, could be used for JavaScript and the Node ecosystems, one of the most popular libraries for this purpose. But one day, a security researcher opened a pull request, which reports and fixes an XSS vulnerability, code injection in JavaScript, including tests for future code regressions, as well as proof of concept examples in his code pull request. As is with open source, though, maintainers are really just trying to do their best, but they can't be there all the time, and there are no legal or contracting obligations for them to support you or me. So this vulnerability was left out in the open with no fix for a year. This security issue and proposed code fix was opened in 2015, but was only merged to and made available as an official release in 2016. When we're all so very much dependent on open source software, we can't ignore the question of where do we put our trust and what are our mitigations and security controls to cope with the risks involved. In 2017, a security researcher working with the Node Foundation conducted a research in which he wanted to assess the state of weak NPM credentials used by maintainers. His work revealed the devastating truth of developers' lack of security hygiene. The security researcher was able to gain publish access to 14% of NPM ecosystem modules. Some of these modules are downloaded tens of millions of times a week and are an essential and key part of a thriving JavaScript ecosystem. The problem was rooted with insecure passwords chosen by well-known maintainer accounts, such as literally the word password as an account password for a maintainer with millions of downloads for their package. Well, what could have happened if this was a malicious actor doing this and not a white hat hacker? I'll let you ponder about that. If our code packages can reach thousands or millions of developers, shouldn't we have more protections in place? As citizens of open source security and community, can we do better for our own account security hygiene? NPM, the largest registry of open source software packages spanning 1.5 million packages to date, has supported two-factor authentication since the end of 2017. Despite all the security incidents and compromised accounts happening throughout recent years, in 2019, only 7.1% of NPM package maintainers have enabled 2FA. Unfortunately, the software supply chain security story isn't resonating enough with developers because in 2020, 2FA-enabled accounts have only grown by merely 2% to approximately 9% of developer accounts on NPM. As cybersecurity expert Bruce Schneier said in his book, Secrets and Lies, humans often represent the weakest link in the chain. A term coined as Linus's Law back in 1999 by Eric Raymond in his work, The Cathedral and the Bazaar, in which he explored the differences between software development as executed within the open source movement and that of enterprises and formally organized companies. Eric stated that given a large number of developers and users, software flaws will be quickly identified. Really? In January 2021, it was discovered that sudo, a common utility installed on many Linux distributions, has a security vulnerability. Specifically, any unprivileged user can gain root access just based on the default sudo configuration. What is so daunting with this vulnerability is that it was hiding in plain sight for a decade, for 10 whole years. Open source registries are open in their nature and allow developers to openly push code packages into them. But what happens when maintainers remove their dependencies out of the registry? That is exactly the story of what happened in 2016 when a maintainer named Azure pulled tens of his open source packages from NPM. One of them was a pivotal package in the ecosystem, and failing to download it now resulted in a widespread breakage of CIs and install processes. At the very least, this incident showed us two things. First, the weakness in how businesses failed to manage their open source software stack, which exposed this soft spot. Secondly, how registries did not foresee this as a problem, and so were not designed to handle this circumstance. Can we really deny being a part of an open source ecosystem? As consumers, as contributors, even maybe as maintainers, we all play some part in a world where 90% of our application code is made up of open source components. what kind of malicious activities and assets can we track back to open source ecosystems? Time after time, we find more and more malicious packages hitting the NPM ecosystem. If you accidentally installed one of these by maybe a typo squatting mistake or by someone planting one of these in a nested dependency tree, which your chances of finding it are basically none, malicious packages aren't just a thing on the JavaScript ecosystem. On March 2021, more than 3,000 malicious packages were published on the PyPI registry. To further show us how attackers can harness open source to their advantage, Alex Burchant published his research in February 2021 about how we exploited design flaws in package managers, registries, and human error to infiltrate into corporations such as Apple, Microsoft, and others. I would like to leave you with the following questions to ponder upon. Are we going to have less or more software in the future? Are we going to use less or more open source software in the future? And lastly, who do you trust? I am Liran Tal, a developer advocate at Snyk, where we build a security platform to help developers build securely with open source software. Thank you for joining my talk.
Wonderful. Thank you so much. If you have any questions, don't hesitate to put them into the chat window. We do have just a couple minutes. I do see some questions. The question from Gabriel, 100 days measured starting on when the lib was published or the date of infection. Not sure if you know that stat, Liran.
That's, if I remember correctly from that research, that's from when the CVE was made public until a fix was provided. So I'll also be happy to share the slides with relevant links to each of those research articles too.
Fantastic. And I know there's more literature also within our resource area in the resource center here at the platform for this summit as well. So thank you so much, Liran. Again, love the hat. I encourage you all to connect with Liran on social media as well to continue the conversation that we have here today.
Thanks, JD.
I encourage everyone to click the green back button and then join broadcast button. We'll see you in the next session.